There are many types of electric motors used for a variety of purposes in commercial industry. One critical task that must be performed prior to installing a motor is determining the motor's correct rotational direction. If a motor is required to rotate in a specific direction, it will have a direction arrow prominently displayed on the frame. But with few exceptions, most three-phase motors are made with symmetrical parts so the motor can rotate in either direction. Since these multi-directional motors are equally efficient in either direction, there's no standard direction of rotation. Therefore, when a three-phase motor is first connected, it may run in either direction, and technicians must be careful to install it properly. While the motor itself can run in either direction without harm, the components that the motor drives may be unidirectional. For instance, running a pump in the wrong direction may cause damage due to cavitation or expulsion of the shaft seal. If the motor's rotation is incorrect for the required application, it can be reversed by simply interchanging the connections to any two of the three power wires. While many motors are three-phase and easily reversible, others are not. For non-reversible motors, you must be very careful to check and double-check that the correct rotation is specified. Unfortunately, many vendors don't make it easy, since the specifications of clockwise and counterclockwise depend upon the direction from which you view the motor. In general, for most electric motors, rotation is specified as clockwise or counterclockwise when viewed from the opposite end of the shaft. This is sometimes called the lead end, since the electrical wires or leads typically connect on this end. By contrast, the rotational direction for hydraulic pumps is specified as clockwise or counterclockwise rotation when viewed from the shaft end. Manufacturers use different descriptions to label both motors and pumps. Some standard labeling conventions are shown here. If a motor or pump is not labeled on the frame, consult the manufacturer for specifications. In addition to rotation, technicians must pay close attention to the frequency and current requirements for a given motor application. Frequency and current can be related by two primary equations. The first relates the frequency to inductive reactance, sometimes called the resistance. The second relates the current to the same inductive reactance. By combining the two equations, we can see that frequency and current are inversely proportional. As the frequency decreases, current will increase. Motors are frequency sensitive, which means that frequency changes can cause speed changes within the motor. If frequency decreases significantly, the motor may experience a large increase in current, which can cause motor components to overheat.